Lesson 0-2, FOIL. Use the FOIL method to multiply binomials. Let's take a look at two binomials. That means an expression with two terms being added or subtracted. Now, when we find this product, we're really going to just distribute. And this is the way we can distribute. We can take the first term and multiply it to each one of these parts, and this one multiply it to these parts. But there's a really nice mnemonic called FOIL. And FOIL reminds you to multiply 4 times to get all of the terms. Now, the F stands for first, so the first terms are multiplied, x and x. So this is x squared. And then the outer, and then that's negative 5x. The inner, 3x. And then the last terms are the two constants being multiplied. And then we go ahead and we combine like terms and we get this. And the same thing can be done over here. Again, FOIL, first terms, these two terms being multiplied to get this. And then we go outer, which is this, inner, this, and then the last terms, which is this. And again, combine like terms. Okay, I'd like to pause the screencast. You stop the screencast and try these 6 problems. And then on the next page will be the answers. Here are the answers. Let's take a look at our next lesson, 0-3, factoring polynomials. Okay, let's first discuss the distributive property. And when we have an expression like this with two terms, if there's a GCF, a greatest common factor, then we need to remove it first. And in this case, it's 4a. So we take 4a out of this expression and 4a out of this expression. And then we again, factor it out using the distributive property, 4a, and then what's left here is a plus 2. And this is what we call factored form, two expressions being multiplied to represent the same two-term expression. Okay, let's take a look at factoring what we call a trinomial where the x squared coefficient is 1. When the x squared coefficient is 1, all we want to do is worry about the factors of the constant, the factors of 6, and we want to find factors that add up to the number 5. And in this case, 2 times 3 adds up to 5, and that's why this is the factored form. We can easily check our work by using FOIL to multiply it out. Again, here is a trinomial where the x squared coefficient is 1. So all we do is we work with factors of positive 12. And what we want to do is look at factors of positive 12 whose sum is going to be negative 8. So now, since the sum has to be negative 8, I'm going to look for factors that are both negative. So negative 1 times negative 12. Negative 2 times negative 6. And already I see that these are the factors I want. So negative 2 and when you add negative 6 will be negative 8. So here's my factored form. X minus 2 and then x minus 6. So the two factors are negative 2 and negative 6. And if you use FOIL, you'll get the trinomial that we wanted. Let's do it again. And again, this is a trinomial where the x squared coefficient is 1. So all we have to do is worry about factors of negative 15, and we got to make sure the sum will be 14. So one of the numbers we can use is we can use positive 1 times negative 15. And you can see this sum is not what we want. But if we say negative 1 times positive 15, when we add these factors, we will get the 14, which is what we want. So now I know what to use. It's going to be x, and I'm going to do plus 15, and then x minus 1. So I'm using a positive 15 and a minus 1. And if I use FOIL, I will get back to that trinomial. Okay, pause the screencast and see if you can factor these 10 examples. And here are the answers. I want you to notice that number 6 is prime. In other words, there was no way to factor that. Let's take a look at dealing with a trinomial where the x squared is not 1. Okay, we have to work with this a little bit more. And remember that the constant in front of the x term is a, and the constant in front of the x term is b, and the constant itself is what we would refer to as c. When we have a constant a other than 1, then we are going to have to worry about multiplying the a times the c term to create negative 18. And we're going to find factors of negative 18 whose sum is going to be 7. And this is going to happen when we work with negative 2 and 9. And when we add them together, we're going to get the 7. So these are the terms we want. Now, there's a little bit more to do on this type of problem. And what we're going to do is we're going to take the positive 7x and we're going to write it as negative 2x and positive 9x. So what we're taking is the middle term and we're rewriting it. And then we're going to factor by grouping. And factoring by grouping means we're going to take a look at these first terms and take the greatest common factor out. And then we're going to look at these last two terms, take the greatest common factor out. And we notice that now they both have this term, 3x minus 1. And when we take that out, we're going to have a 2x plus 3. And this is what we call factored form. Okay, there is a faster way to do it, which what we call the AC method. And the AC method is a times c. So you're going to take this a term and multiply it to the c term, and that's going to be negative 18. And what we want to do is we want to find two factors that make 7. This is actually the same problem we just did a few minutes ago. So I'm looking for two numbers that multiply to negative 18 but add up to 7. And remember, we just found them. They were positive 9 and negative 2. These are the two terms that make negative 18 but add up to 7. And so then we can go ahead, x squared plus 9x minus 2x minus 3. And again, we're going to do factoring by grouping. So the common factor is 3x. So we're going to have x, 2x plus 3. And then over here, the common factor is negative 1. And then this is 2x plus 3. And so our common factor is 2x plus 3. And then when we remove that factor, we're going to get 3x minus 1, which is the same answer that we had just a few minutes ago. Okay, let's do this again, and we're going to use the AC method. I'm going to multiply the a term and the c term to make negative 15. And remember, these factors must add up to negative 2. Now, negative 2 is this b term right here. And so I can see the answer is going to be negative 5 times positive 3, because I can see these two make negative 15 and they add up to negative 2. So now I have 3p squared, and then I'm going to write minus 5x plus 3x. So I'm replacing the p, actually these should be p's, and then minus 5. Okay, and now I'm going to do factoring by grouping, p, and I'll have 3p minus 5, and then the greatest common factor here is 1. So p minus 5, 3p minus 5, right? And then so this is 3p minus 5 is one of the common factors. And then when I remove that, that's going to be p plus 1. And so here's the factored form. One more time again, we're going to take the a term and the c term. That's going to be negative 18. I know I want the factors to add up to 3. So I know I want a big number like a positive 6 and negative 3. We'll make negative 18, and their sum will be that. So then this is going to be 2n squared plus 6n minus 3n minus 9. Greatest common factor, 2n, and plus 3 minus 3, so then this is n plus 3, and I see my common factor n plus 3, and then when I factor it, I get my other binomial, and this is complete. Okay, please pause the screencast and try these two problems. And here's the answer. Let's take a look at some other special products. When we multiply a binomial to itself, we get a real special situation where the trinomial has a square in the front, a square in the back, and the middle term is 2 times each one of those terms that has been squared. So let's take a look at this one. We can see there's a square here, it's right here, and we can see there's a square here, right here. And so 2x and 5, and if you double it, that makes this middle term 20x. So this is a great candidate for what we call a perfect square trinomial. In other words, it's going to be 2x plus 5 to the second power. In other words, the factors are both exactly the same. The other kind of special product is what we call a difference of two squares, where the first term is squared, the last term is squared, there is no middle term, and there's a minus. And that only happens when this kind of factoring is here. So a and a B and a B, one will be plus, one will be minus. And that's because the outer and the inner, this is going to be negative AB, and this is going to be AB. They are going to go to 0 because they're inverses of each other here. So when you see a perfect square here and a perfect square here, you know that it's going to be this kind of factoring where the x's are split up, the 2 is split up, you have a plus in one and a minus in the other. Okay, so let's take a look at this. Now this looks like one of these, a difference of two squares, and I know this 4n squared makes this, and 3n squared. As soon as I see that, then I know that I can factor it. I'm going to put a 4n, and I'm going to put a 3 here and a 3 here, a plus in one and a minus in the other. If you see a square and a square here, you know the two squares, you can factor them. 2m, 5, a plus in one and a minus in the other. And here this looks like a square in the front, a square in the back, and it looks like these two terms right here times by 2 make that middle term. So this is what we call a perfect square trinomial. 4b, 5, and 5. Since the middle term is minus, both of them will be negative. And so this is the factored form. And you can actually write it this way with a square in it if you want. This is a square, this is a square. So we know this is a perfect square trinomial. 2x, 1, 1. Since the middle term is minus, they both have to be minus. And you can actually write this like this, perfect square trinomial. Your turn, stop the screencast, and here's the answer.